This is May 15th, 2020, and this is a commentary on Pascal Boyer's book, Religion Explained, the evolutionary origins of religious thought. And we are, at the moment, gaining sort of access to how thought itself operates. If you think of it this way, there's all this data coming in, and we can't pay attention to all of it. So if we're going to learn something, if we're going to move on, then we need to separate out some of that. And the mind, over its evolutionary development, has created a series of inference systems that pick out some of those, turn them on and turn them off. So we had been talking about that, and a number of the experimental things that have given us insight into these aspects of the mind come from children. And so he has a section here called What Every Nursery School Child Knows. And he begins with the sort of description of children, which basically says little children don't seem very bright. 2-year-olds are clumsy. They have no manners. They literally speak with a strange accent. They literally couldn't get themselves out of a paper bag if they were in one. And yet, the reality about children is that they can learn a lot because they know a lot. Their brain is organized in such a way that, surprisingly, they begin to make sense of the world they're in, and it's a complex world indeed. However difficult it may be to believe, little children may in fact be very bright and have to be very bright. And they do it by inferring things from what comes in. So he begins with an example of crocodiles. If you dissected a crocodile, you looked inside of it, you would see all these organs, these muscles, this bone, and the assumption for adults anyway is that you know one crocodile, you know them all. The inside, if you opened them up, you don't have to open up 200 of them to ensure that you understand what's inside them. We just assume that all members of a species have a similar innards. We just assume it. It's just a shorthand way of looking at various species. We don't have to go through each one and learn anew this one and that one and that one. We just know this one, the concept of crocodile. Okay. Interestingly enough, even young infants, young children, share this tendency to assume things like the innards of animals are all of the same species, are all similar. They know if something's called a crocodile and another crocodile, that they're going to be the same in a number of ways. Children, however, are much less certain about the innards of telephones and televisions. These man-made objects, these artifacts, are do not seem to lend themselves to that assumption. So they may have a good idea what's on the inside of a crocodile, never having seen the inside of a crocodile. Children have the vaguest notion of what is inside an animal's body, yet are quite sure that whatever is inside one mouse is also inside all other mice. There is an essentialist kind of understanding. So if you were to take an animal like a cow, and this is the example he uses, and you were to surgically make it look like a horse, adults would certainly identify it as a cow made to look like a horse, and infants do too. That's the essence of cowness is not taken away simply by having a little surgery. That cow is permanently a cow. Now, this is interesting because it corresponds to the way we classify animals into genus and species. The genus, each animal only has one genus. All animals are assumed to belong to the same class. Not that this is not true of kind concepts outside of the natural order. So why do these things move of their own accord? That would be a very curious thing. Why do they move of their... And 6 months old showed that they too are sensitive to the differences between physical causation, that is push, pull, hit, and social causation, that is chase and avoid. They may not have words for those concepts, but they can assume them under certain circumstances. Before the child has acquired the concepts of chase and avoid, they assume chasing and avoiding. Older children, say around 3 years old, have the definite expectation about the difference between self-propelled and non-self-propelled objects in the environment. Real animals could move on their own accord, but statues could not. Now, it's interesting that the children could point out that the statue is not going to be self-propelled, and the animal is, but they can't exactly explain why. They don't have the why part of it worked out yet. They might say something like, the statue doesn't have legs. Well, when it's pointed out that they do have legs, then they say, well, then those legs don't work. So the ability to describe is not necessarily what an infant has, but an infant does assume that animals are self-propelled and other things are not. Children have the principle, they have the systematic intuitions, yet they have no explanations for them. This is because intuition produced by a specialized system, that is, even in adults, separated from the conscious aspect. So the assumption of self-propelled or not is an unconscious evaluation. Are there different people out there? Most of us know something about the facial recognition of infants, that very quickly different faces become very clear to different infants, being the primary caretaker, mother usually, is a well-known face, and that the child's brain is built to assume it is that the differences between human-like objects are far more important than those between, say, two different mice or two different toys. So the faces of the people involved in the child's life are important, and so the assumption is, and the clear ability to differentiate. The newborn's brain is equipped with highly specialized capacities. The child does not learn to imitate, but uses imitation to learn. So if the child is taught a gesture, for instance, waving, we very young children learn to wave goodbye. The waving is an imitation. As a matter of fact, if you wave, the child will wave. It's through imitation that the child learns. That's the point that is being made here. Some mechanism in their brains and in ours keep track of how many objects are around. So another thing that happens is counting the number of people in the area, keeping track of those faces and knowing the different faces, and keeping track of the number of. This is not true of every species. It is when people used to hunt crows, the sad truth is that crows can't count. So if 3 people walked out to the area where the crows were, and then 2 left, and they were all in blind of some kind, the crows would assume that they had all left, when indeed there was still 1 there. They couldn't count, whereas a child very much can. Okay. Now, it's not easy to get into a child's situation so that you can find these things out, but there are interesting ways of dealing with these things. Ingenious techniques that measure how surprised and how attentive infants are by tracking their gaze or monitoring the intensity with which they suck a pacifier. When infants watch repeated displays that conform to their expectations, they quickly lose concentration and start looking around. So if you're dangling something and momentarily the child will pay attention, but if you keep doing that, it gradually loses interest. To sum up, when a young mind is by no means a simple mind, many of the specialized capacities we find in adults are already present in infants in the form of particular expectations, preferences, and ways of inferring. Because the mind is biased to ignore all sorts of facts about the world and to attend only to some of them, and that's what the inference system does. It allows the infant to assume certain things about the world, but not other things. Now, the interesting thing is we start thinking about the concept of animal. But if you're dealing with young children and infants, you have to kind of reduce that from animal to animal-looking thing to self-propelled thing to a thing in erratic motion. So whatever we will find at birth will not be, strictly speaking, the animal concept, but something that normally leads to something that leads to something that builds an animal concept. The same is true for all other concepts. So there is a kind of vestigial understanding, assumption about things that are moving erratically. But then that is gradually developed into a self-propelled thing, realizing that it's not erratic motion, but it's self-propelled motion, and then realizing that it's an animal-looking thing, and then realizing it's an animal. That's a progression of abstraction. That is the learning process, which begins with just noticing the erratic movement, and then being able to begin to see it as causal. Extremely early developed structures with huge consequences for the child's future in terms of concepts. So they aren't concepts yet, but they begin to focus the attention of the infant. Now, Ruth Millikan, a philosopher, has called these concepts are much less descriptions than they are skills. So we learn the skill of animal. We learn to identify animals, and it's a skill to learn how to identify animals. And we begin with erratic motion, and then self-propelled motion, and then animal-like, and then animal. Ontological categories are, in fact, consist of a set of switch setting, activating and inactivating. This is the inference system. So we begin with the inference system, but it gradually builds up internally a sense of concept. One can always become better at a particular skill. If you think about it in terms of, well, just walking, 8 months to a year old or so, most normal children walk. And the process of walking is an interesting one, where they first sort of learn to balance, and then they'll maybe take a step with somebody holding them. But it's a skill acquisition. That's a physical skill, but these are mental skills. Loose talk of innateness seems to imply that we will find in infants the same concept that we observe in adults, but that is not true. We are not encyclopedias of the world. We are filled with inference systems that get us started down the track to learning about our world. In other words, the genetic type of the individual produces for the individual the ability to learn. This is definitely noticeable in linguistic skill. Language acquisition is over a number of years, but they're young years, and for a normal child, those skills are really about hearing and mimicking. And a normal environment is indispensable to development. So it's not nature or nurture, it's both. These are also human skills. other animals may not know the distinction. He uses, Mary had a little lamb, and he indicated that perhaps a giraffe wouldn't know the difference between Mary and the lamb, possibly, because it wasn't important to the giraffe. It wasn't part of their inference system. And inference systems are the way that we humans do it, but other animals may not do it that way at all. So, having particular ontological categories is a matter of choice. The world lends itself to many different ways of categorizing its contents, and the choice depends on which species you happen to belong to. Face identification is a very human thing, but not necessarily. We aren't terribly good at recognizing the faces of other animals in distinction. We need years of care, and we need to cooperate with each other in order to grow. We need, of course, to know about which animals that we're going to be chased by and which animals we are going to run after for food. We have a bias toward inferring that fairly quickly. We also recognize tools and the use of those, the function of those tools. So tool making is something that we do, and so we know a lot about tool manipulating. Having special inference systems for tool handling confers a real advantage in this domain, allowing humans fast and flexible acquisition of complicated tool-making techniques. The diffusion of technology, as we might call it in a more abstract way. Okay, this section is really, he's looking primarily at the research done by a number of people in the infant and children area to show that what I would call vestigial inference systems are what help us cut down all of the data coming in and putting it into that child turns out to be considerably smarter than we give credit for, because the child doesn't live up to adult standards and cannot operate an adult level. Nevertheless, we know that child is learning through imitation, learning through making assumptions from their inference systems. And those inference systems elaborate the concepts that will become their use in adulthood. Well, okay, we've got a little bit more to do in chapter 3. Is the thing on tool and evolutionary biology, the life of a cognitive niche. These are the titles of the things that we're going to look at tomorrow. Decoupling and constraints, who knows what that is? And then we come to the end of chapter 3. But all of it is reminding us that we do not have this encyclopedic knowledge. What we have is inference systems that help us to assume things about the world that we would not otherwise know. Anyway, have a good day.